Hello students, today we are going to see some more interesting and important questions from Ms. Chouhan's Organic Chemistry, Aldehydes and Ketones, and the question from 61 to 70. Come on, let us discuss the first question. Carbonyl compounds can generally be converted to hydrocarbons. Which reagent it is possible among these options? First one, hydrogenation, that is H2 platinum, right? Ordinary reducing reagent. And the second one, lithium aluminum hydride, very strong reducing agent. Okay, very strong reducing agent. Carbonyl compounds converted to primary alcohol and secondary alcohol, respectively aldehydes and ketones. This is hydrazine along with the KOH. This is actually Wolff-Kishner reduction. You know very well. Carbonyl compounds can be converted to hydrocarbon through Wolff-Kishner reduction or Clemenson's reduction. Wolff-Kishner reduction, it is a basic medium, whereas Clemenson's reduction, it's an acidic medium. Right. Okay. Now, the last one here, K2Cr2O7 along with H2SO4. This is very strong oxidizing agent. So, strong oxidizing agent, carbonyl compounds converted to carboxylic acid. Right. I hope you got the clear idea. Now, which is possible to convert hydrocarbons means Wolff-Kishner reduction. Right. Now, I just mentioned each and everything with writings, explanations. Right. Now, here, this is a hydrogenation, which is not at all possible. Whereas this one, carbonyl compounds, C double bond O, this is carbonyl compounds. No? For example, this is aldehyde. So, aldehyde converted to primary alcohol with the help of reducing agent. And the same way, this is R, C double bond O, R dash. This is keto group. And the same way, lithium aluminum hydride. This is lithium aluminum hydride. I just mentioned LHA. Right now, this is actually secondary alcohol. Right. Okay. I hope you got the clarity. For lithium aluminum hydride, aldehyde can be converted to primary alcohol and ketone can be converted to secondary alcohol. Of course, Wolff-Kishner reduction, which is possible to convert hydrocarbon. So, R, C double bond O, H or R, C double bond O, R dash. Both can be converted to with the help of N2H4. Hydrazine along with the KOH. This is a basic medium, whereas Clemenson's reduction, it is an acidic medium, zinc along with the zinc amalgam, that is HCl along with it. That is actually what it is, acidic medium. So you will get RCH2, like that it will be. And the same way here, RCH2 R dash. So this is the way it can be converted. I hope you got the clarity. Now, which is possible to convert carbonyl compounds into hydrocarbon means this is only possible. This is actually Wolff-Kishner reduction. Right. I hope you got the clarity. And finally, what it is, this is oxidizing reagent. Right. So, oxidizing reagent, what it is, it can convert carbonyl compounds. Carbonyl compounds can be converted to carboxylic acid group. Right. The correct option is C. That is hydrazine along with base, strong base while heating. This is actually what it is, Wolff-Kishner reduction. So this is only the correct option. Carbonyl compounds can be converted to hydrocarbon, which is leading option. It is hydrazine along with KOH. Even Clemenson's reduction also will be coming. Clemenson's they did not mention here. Generally, Wolff-Kishner reduction, it's a basic medium, and Clemenson's reduction, it is an acidic medium. Already we have gone through this kind of questions in our last video only. Hope you got the clarity. Come on, let us go to the next question. The next question, here only it is available. So here in this is alkene which is attached with ethyl group. Alkene connected with that, reacting that reagent ozonolysis, Ag2O, sodium borohydride and H plus ion, that is acidic medium. What is the final product? So that is only the question. So what is the final product? You have to identify with these among option. Yes. Now generally alkene, that is, I just give the example so that it will be easy for you to understand. So this is alkene compound, CH2 double bond CH2, right, combined with ozonolysis. Right. So what happened? I'm just giving that example to identify. So all these reagent which is reacting with this compound, right? Okay, now this is first one ozonolysis, second one Ag2O, third one sodium borohydride, and fourth one acidic medium. Okay, now this is an example I have taken. So ozonolysis, the bond breaks over here. So what happened? CH2, both the bonds it breaks, right? CH2, and then here one oxygen atom, both attached, and here like this it will be. Then what happened? Slowly the bond breaks, which again it is reacting with what it is, zinc dust as well as HCl. So what happened? Further it will not go for the carboxylic acid to avoid. So for that is the reason zinc plus HCl we are adding. Right now here what happened? The same idea only. So what is the product you will be getting? CH2O H2O means nothing. HCHO. This is formaldehyde. 2 molecules of formaldehyde. This is an example I have given. Now, in this, here they have given one compound. Now, we have to check all these reagent final product. Let us check. So, here, this one. Yeah, now, the reactant, which is like that, right? Right. So, this is ethyl group which is attached. Now, this is double bond. First one, it is ozonolysis. Right. Now, what happened here? Here also the bond breaks now. So, here one oxygen atom, here one oxygen atom, and both connected here one oxygen atom. Right. Now, here what happened? So, the bond breaks over here also. Right. Here also the bond breaks over here. Now, here aldehyde CHO, here CH2, ET, and O. So, that means keto group also it is available, and aldehyde group also it is available. I just mentioned this structural formula here like this. Here C double bond O H. Now here double bond O ET like this. The compound you will get after zinc dust along with HCl, you will get that only. That is the product. That is not the final product. That is what it is. When it is ozonolysis product is this one. The second reagent what it is? Ag2O. Ag2O it is nothing. What it is? Tollens reagent. Tollens reagent. So, tollens reagent, what happens? Actually, tollens reagent will give positive test for what it is? Aldehyde. It will give positive test for aldehyde only, not for keto group. So, tollens test will give positive for aldehyde, and the aldehyde will be converted to carboxylic acid. So, what happened? This will become a carboxylic acid. Now, I just draw the structural formula here. So, here ET as it is, double bond O. Here, I just put it here O. And this is a C double bond O, here OH. Right. Okay. Now you got the tollens reagent. So this is the first one and this is the second one. And the third one, what it is? Strong reducing agent. What it is? Sodium borohydride. Sodium borohydride. So sodium borohydride, this keto group, it will go and react. So usually strong reducing reagent converts keto group into secondary alcohol. Right. Already we have gone through, no? So this is secondary alcohol. So here ET as it is, that is ethyl group, here OH. Right. Now C double bond O, here OH. So this sodium borohydride will not affect the carboxylic group. It will affect only the keto group, and keto group converted to secondary alcohol. Yes, I think you got an idea. Okay, now this is the third one. Now fourth one, it is H plus ion, acidic medium. Now what happens to this point? So here what happened? Here during the reaction with acidic medium, what happened? Esterification you will get. So how do you get? Here you are getting what it is? Alcohol group. Here you are getting acid group in the presence of acidic medium. So what happened? It started losing the water molecules H2O, and you are getting ester. I hope you got the clarity. So what happened? Here water molecules, it releases water molecules. No, so the bond takes over like this. Like this. Okay, here O and here ET will be coming. ET will come this side, and then here C double bond O. Here like this, you will get it. The bond which is going to connect over here. So this is the way you will get the compound final product is like this only. I hope you got the clarity each and every point. So this is the first one with ozonolysis. This is the second one with tollens reagent. This is the third one with sodium borohydride, and this is the fourth one with acidic medium. You are getting esterification. Final product is this. Now come on, let us check which is the correct option. Option A. Yes, option A, it is ester. Yes, 100% it's correct. Now let us check other also. Now ethyl group has to attach over this side only, not here. So this is wrong option. And one more oxygen is available, but they did not mention over here. So this also, it is not the correct option. And here also there is no, they did not mention that. So all these options are wrong. Only this is the correct option. I hope you got the clarity. Now, as we are observing the reactions only, you will come to know that each and every step along with that final product. Okay, come on, let us go to the next question. Next question. Here, which statement about aldol condensation is correct? Lewis acid is commonly used as a catalyst. The initial step is probably the formation of carbon anion. Lewis base is employed to induce carbocation formation. The carbon chain is lengthened through the elimination of 1 mole of water. See, actually, before analyzing all these options, let us come to know the aldol condensation reaction. So, aldol condensation happens through dilute NaOH. That is very, very important. Generally, aldol condensation and Cannizzaro reaction, just the opposite. Here, we are using dilute NaOH. That is taken for alpha hydrogen. Alpha hydrogen only it is possible aldol condensation. Whereas Cannizzaro reaction, concentrated NaOH or else 50% of sodium hydroxide or potassium hydroxide with what it is, there is no alpha hydrogen in that aldehyde or ketone carbonyl compound which does not have alpha hydrogen. That only it will be eligible for Cannizzaro reaction. Both are having just the opposite. Right now here in this aldehyde CH3 CH double bond O combined with another 1 mole of what it is aldehyde, that is HCH2 CHO. Right, now this is dilute NaOH. I'm not bringing that mechanism, just I'm giving this idea only. So the same thing here also, nucleophile which is going to attack, that is also fine. That is way also we can bring it. Now here in this point here, from here one high, CH3 CHO only here. So this is actually positive charge, one hydrogen, and this is negative charge, because this is alpha hydrogen. From this one hydrogen which is removed, where it is removed, actually this is lone pair of electrons are there. No, the lone pair of electrons are attracted towards the positive charge of H plus ion, that is alpha hydrogen, and this negative charge which is attracted towards the positive charge of carbonyl carbon. Right, now what happened here? CH3 CHOH CH2 CHO. Right, now from here losing water molecule, and then you are getting what it is, alpha beta unsaturated carbonyl compound. That is another one more point, but from this option which is the correct. So this is a carbene anion formation. This point only I just to bring it over here. This is carbene anion formation. This point only we are bringing out here, carbene anion formation. This carbene anion formation only brings that what it is, aldol condensation to get that product. This is actually intermediate product only. Then you are releasing that water. Then final product what it is, alpha beta unsaturated carbonyl compound you'll be getting. But this is an intermediate through what it is, carbene anion formation. Right, now here, which is the correct option? Lewis acid is commonly used as a catalyst. Here we are not bringing that Lewis acid only. Lewis acid, where can we use it? That is for Friedel-Crafts reaction. Actually, Lewis acid is electron accepting. Right, now second, so which is the correct option? This first option, it's wrong. And the third option, Lewis base is employed to induce carbocation formation. This also will not be correct, because it is electron donor. Here we are not bringing Lewis base only. Right, now the carbon chain is lengthened through the elimination of 1 mole of water. Here carbon chain lengthened through the elimination of here. In this point we are not bringing the losing of water. Next category only we are losing that water. But here this option also, the first initiative, it is actually what it is, initial step, it is carbene anion formation only. So that is the intermediate. So which is the correct option? Option B is the correct option. Probably the formation of carbene anion. That is only the correct option. I hope you got the clarity. The next question here, compound gives a positive test with I2NaOH, that is iodoform test, and is extracted from benzene by saturated sodium bisulfite. It may be. Now generally I would like to give that idea, that is a concept way here, which is the eligible for iodoform test. Right, okay, let me write and give you a clarity for you. So this is iodoform test. So iodoform test, what are the main eligibility for that? Means first and foremost, it is terminal group, it has to be CH3C double bond O. That means it is methyl keto group, it has to be present. Methyl keto group. So the terminal group, it has to be methyl keto group. Okay, now or else second point, what it is, secondary alcohol, it has to be present. That also the terminal CH3 CHOH, because it can be converted to keto group, that is methyl keto group. So this is secondary alcohol. So this is the second point. And the third point what they have given, and this can be saturated by sodium bisulfite. So sodium bisulfite, which is possible, means here I just mentioned that third point here. Here sodium bisulfite, here yeah, NaHSO3. So this is, it can be eligible for what it is, aldehydes or methyl keto group. Here also keto group only, but that is what it is, methyl keto group. Methyl keto group, not all the keto group, only methyl keto group. So these are the three main points we can consider for iodoform test. So first one, what it is, methyl keto group, it has to be present in the terminal, and the same way methyl keto group or secondary alcohol. And the third point what they have given in the question, saturated, extracted from benzene by saturated sodium bisulfate. So saturated sodium bisulfate, that point it will be eligible for what it is, aldehydes or methyl keto group. Okay, first and foremost, iodoform test, methyl keto group, it is a mandatory, that only eligible for what it is, iodoform test. Okay, that means here aldehyde group is available, CH3 CH2 4 times CHO, aldehyde group it is there, but that is not methyl keto group. So this will not be the correct option. Right, so first one which is not correct option, and the second one CH3 CH2 thrice COCH3, it is what it is, methyl keto group. Yes, it is available. Let us check other two also. Here CH3 CH2 CO CH2 CH3, here actually terminal methyl keto group. This is ethyl keto group. This is completely ethyl keto group, which is not possible. Simple way to identify the answer. I'm giving all these tricks for you. Right, now the last one here, CH3 CH2 4 times CH2OH. CH2OH, it is a primary alcohol. Right. Secondary alcohol means what it is? CHOH only, it is a secondary alcohol. Right. This is a secondary alcohol. But whereas this is CH2OH, it is a primary alcohol. Now, which is the correct option? Your eyes are telling that which is the correct option. Option B is the correct option. Option D, what it is? Methyl keto group, it is there. And one more thing, methyl keto group, it is possible for what it is saturated, extracted from benzene by saturated sodium bisulfite. Yes, it is possible. Okay. So, here methyl keto group will be answerable for iodoform test. So you will get final product here. What it is? I just mentioned here. Here CH3. Yeah, this is the next question I just mentioned. Here only I'm bringing the answer. CH3, CH2 thrice COOH. Right? Why? Because here actually one carbon, this CO group can convert it into what it is? Acid group. The other carbon CH3 it is there. No, that is converted to iodoform CHI3. So that is what. So methyl keto group, for end of that methyl keto group, 2 carbons are available now. So that one carbon has become carboxylic acid, the other carbon can convert it to what it is, haloform. That is the reason. End of that, it will be easy to bring the answer. Right, iodoform test, in that way we can bring it. Hope you got the clarity. So whenever you are thinking of iodoform test, end of the terminal group, methyl keto group or secondary alcohol group, it has to be mandatory because secondary alcohol can be converted what it is, keto group. So keto group, that is methyl keto group, can be converted into what it is, iodoform. It will be eligible for iodoform test. Hope you got the clarity. Okay, come on, let us go to the next question. So which is the correct option? Option D is the correct option. Okay, now question number 65. Which of the following compound on reaction with excess of CH3 MgBr? This is Grignard reagent. Grignard reagent. Okay, CH3 MgX. So this is Grignard reagent and the subsequent hydrolysis along with water H2O. So to give the tertiary alcohol. See, where do we get the tertiary alcohol? Very simple. See, generally aldehyde group or CHO can combine with the CH3. This is general idea. CH3 MgX. One more thing, this is a very simple way to bring the answer. Grignard reagent, it is completely very interesting and it's easy to bring that answer. So aldehyde generally combined with Grignard reagent, you will get secondary alcohol. Right? And the same way, keto group, when Grignard reagent combined with the keto group, you will get tertiary alcohol, CH3 MgBr, right? CH3 MgBr, right, or Br or X, that is haloform along with the H2O. So what you will get it, this is only tertiary alcohol. Right. Now, here what are the options they have given here? Epoxide also they have given, carboxylic acid they have given, and the keto group it is there. Of course, that is a methyl keto group. And I think whenever you are thinking about methyl keto group, you please remember iodoform test also, so that will be helpful. And here, of course, aldehyde. So just now I mentioned the aldehyde group can be converted to secondary alcohol with the help of CH3, that is Grignard reagent, CH3 MgX, and keto group can be converted to tertiary alcohol. Acid group, when it is reacting with what it is, Grignard reagent, you will get hydrocarbon and what it is, ester you will get, and then epoxide you will get secondary alcohol only. Okay, each and everything I just to bring that idea, that explanation I would like to give you so that it will be easy whenever the question comes. Right now here what it is, ET CH double bond O combined with the CH3 MgBr. Right. So here what you will get it, this is positive charge and this is negative charge. Right. Now here what happened, this negative charge which is going to attack over this carbonyl carbon, whereas this positive charge which is going to attack over this lone pair of electrons. So what happened, you will get along with what it is, water molecules. First we will write that intermediate, then we will go for hydrolysis. Here ET, that is CH, here CH3, here OMgBr. Got it? So this is actually what it is, negative charge. Now it has become what it is, negative charge. Right? Now again, water hydrolysis we are bringing, right, H2O. So what is the product you will be getting? CH3, that is ET. ET it is ethyl group. So ET, and here CH, here CH3. And what it is, here OH. Okay, so as I mentioned, it is a secondary alcohol. CHOH, it is a secondary alcohol. When aldehyde combined with the CH3 MgBr, you will get secondary alcohol. Right? So this is the first option, A. So you are getting secondary alcohol. What they are asking, tertiary alcohol only, that is mandatory. Second one, what it is, the option, that is ester, that is CH3, here actually C2H5, right? C2H5, C double bond O, O, CH3. So this is ester combined with CH3 MgBr. Now, this is actually ester group. Now, what happened? The same, this is minus charge and this is plus charge. No? So, what happened? This minus charge which is attracted towards the carbonyl carbon. Now, this is actually leaving group. This point which is leaving group. Now, what is the product you are getting? So, here you will get C2H5, C double bond. Oh no, this is O, MgBr. Right? MgBr which will go and attach over there. Now, here what it is? CH3. Right, the CH3. Now again, this will react with another mode of CH3 MgBr. Why? Because this is intermediate, right? So this is CH3 MgBr. Because this is ester, no? So we need another one more molecule of what it is, Grignard reagent. So what is the product you will be getting? So here, this again, which is going to attract it towards this point. So CH3, here C, here what it is, CH3, and again here CH3, here OH, right? And tertiary alcohol you're getting, right? And then Mg, here Br, and here what it is, here OH. So this is actually water hydrolysis along with water hydrolysis. So you are getting what it is, tertiary alcohol. We want tertiary alcohol only, right? So we want tertiary alcohol. This is the tertiary alcohol, right? So ester group 2 moles of what it is, Grignard reagent to get the tertiary alcohol. Of course, anyway, we are getting tertiary alcohol in the question, which can get tertiary alcohol. No? So this one, and the third option, which is the third option, carboxylic acid, right? Okay, so each and everything, let us check. So carboxylic acid, of course, this we got it, COO here, we got it, but still we just go for the reaction to identify. Now carboxylic acid, already I mentioned, carboxylic acid along with the CH3 MgBr, acid-base reaction. This is actually what it is, acid-base reaction, C2H5 COOH combined with what it is, CH3 MgBr, right? So you will get what it is, CH4 you will get, and Mg, you both the side, because 2 valent, right? So this is Br, and this is what it is, O C double bond O Et, esterification, like, okay. So the hydrocarbon, that means methane, you'll be getting. So this will not be the correct option, but you should know that all reactions, that is what I just mentioned. Finally, epoxide, when epoxide combined with what it is, Grignard reagent, what happens? So here CH3, CH, here CH, right? And both combined together, oxygen, here CH3. So when this one reacts with the CH3 MgBr, right? Now what is the answer you'll be getting? The same way, CH3, here CH, here oxygen. So here you will get minus charge. Here the bond breaks over here. So here CH, here you will get what it is, CH3, and here CH3, right? So here MgBr, no? So here positive charge which is going to attach. So here MgBr. So water hydrolysis. This is intermediate product, right? So here H2O. So what is the product you will be getting? CH3, CH, here OH, here CH, yes, CH, here CH3, here CH3. So that means what is that? What kind of alcohol this is? The secondary alcohol. So CHOH, it is a secondary alcohol. What they are asking in the question, tertiary alcohol only. Now, why I brought all these examples? No, so easily you can identify the answer. Epoxide, when it is combined with the Grignard reagent, what is the product? Ester, when it is reacting with the what it is now, Grignard reagent, what is the product? Aldehyde, when it is reacts with the Grignard reagent, what is the product? So you will come to know. So which is the correct option? Here, ester can be converted to keto group can be converted to what it is, tertiary alcohol. So this is approximately, this is what it is, keto group, right? That is what I just mentioned. Hope you got its basic idea and you got the clarity, I think so, right? Come on, which is the correct option? Option B is the correct option. Yeah, come on, let us go to the next question. The next question, A plus B, give the product, this one. Okay, now this is actually C double bond NOH. C double bond NOH, generally we can say it is oxime. Okay, in the aldehyde, what we say? C double bond NOH, it is oxime product. Oxime product. How do we get that oxime product? Generally, keto group combined with hydroxylamine. Keto group combined with hydroxylamine. I just to give that idea, R dash C double bond O combined with hydroxylamine. Hydroxylamine, what it is? NH2OH, it's a hydroxylamine. I just to bring that idea, H2N OH. I just to put it ulta for you to understand. So this is not by hearting subject, this is understanding subject, right? So here R dash, both combined together, C double bond NOH. This is what I just mentioned. What it is? Oxime product. Right. Now here what it is? Keto group combined with hydroxylamine. Come on, let us check that. A plus B. What is this? Actually, aldehyde, which is not possible, but here aldehyde only it is available. So this will not be the correct option, of course. Right now here, this is also aldehyde and hydroxylamine. Yes, this is CH3, CH2OH, neither CH, benzaldehyde, benzyl aldehyde. Both will not be the correct option. Why? We required what it is? Keto group. Right now here, PH, C double bond O, CH3. This is hydrazine. NH2, it is a hydrazine. Hydrazine cannot give oxime because hydroxyl group only. Hydroxyl amine. This is called what it is? Hydroxyl amine. So PH, C double bond O, CH3 plus NH2OH. So this will not be the correct option. Now here NH2OH, it is available. Yes. Now keto group also it is available. Yes, of course. What is the product? The phenyl group which is attached with the C, NOH. Yes, it is available. The same. I just to give that this is an example. Here they have given A plus B. So this is phenyl. keto group. I just bring that idea for you. So phenyl keto group only, right? So this is pH, right? So this is pH. Here C double bond O, here CH3 combined with what it is? H2N, H2N OH. So this is actually, right, now here what you will get it? So this is phenyl group, right? Now here C double bond N OH, here CH3. So this is only the product what we are receiving from that compound. I hope you got the clarity. Now how do we get it? So hydroxylamine, it is different from hydrazine. So here what is it? Oxime means C double bond O N OH. So that is oxime. So how do we get that oxime? Keto group combined with hydroxylamine. I hope you got the clarity. Come on, let us go to the next question. And CH3COOH, that means acetic acid combined with calcium hydroxide. What is the product? See, generally here also one concept level question. So acid, that is carboxylic acid, combined with the strong base, that is calcium hydroxide, you will get keto group only. Right now here I would like to give that explanation. Here what it is? CH3, here CH3, C double bond O, OH. This is not one molecule, two molecules of carboxylic acid, that is acetic acids, plus here I just put it CH3, C double bond O, here OH, carboxylic acid, combined with the CaOH twice. Now what happened? This is acid and this is base. Anyway, it releases water, salt and water, right? So now we are getting salt and water I just mentioned. So here OH is there, no? This is acid. So it releases H plus ion. So it releases H plus ion. So H plus ion, which is combined with OH, you are getting what it is? Water. Now here what happens? CH3, C double bond O, and here what it is? CH3, C double bond O, here oxygen, one more oxygen, because one oxygen it is pending, right? So both connected Ca, because Ca 2 plus ion, no, that is what. Alright, I hope you got the clarity. Now this is a salt and water, already water releases, I just mentioned here. And this is a salt, this is acid and base, you are getting salt and water. Now this will not be quite. Why? CaCO3. Now what happened? CaCO3, right? CaCO3, you are getting no CaCO3. So CaCO3, when you are heating, when you are getting that heated compound, so you will get what it is? CaCO3, which is releases CaCO3, calcium carbonate, which is releases. Then what it is there? CH3, COCH3, right? What it is? CH3, C double bond O, CH3. Keto group we are getting. That is what I just mentioned. Here carboxylic acid combined with the strong base, you will get keto group I just mentioned. Right now here, which is the correct option? This is aldehyde. CH was aldehyde, which is not correct option. And of course this is keto group, 100% it is correct. Let us check other two. This is secondary alcohol, CHOH is secondary alcohol, which is not possible because this is strong base and this is acid. So naturally you will get acid base. This is a simple concept. I hope you got that idea. Now then this is a primary alcohol, CH2OH. This is a primary alcohol and this is a secondary alcohol. Now which is the correct option? We want the keto group. Yes, we got that keto group. Now I think you got that idea. How do we analyze such kind of questions related to this point? So this is carboxylic acid combined with the strong base. You are getting salt and water. Alright. So salt, when you are getting what it is? Keto group. Alright. Now come on, let us go to the next question. The next question, which of the following does not form a stable hydrate on addition of water? Generally, carbonyl compounds combined with water, you will get hydrate formation. Okay. So aldehyde hydrate formation, it's more stable than ketone. You know why ketone is having less stable? Because steric hindrance is available. That is the reason. But in that option, everything keto group only it has mentioned. Okay, now let us check one by one which is less stable among these. Right now here the first one here option A, here option A, right? So option A, pH, C double bond O, 3 keto group is available, right? So C double bond O, here pH combined with the water molecule. So what you will get it here pH, C double bond O, here C, here geminal diol you'll be getting, right? So here OH and here OH, right? And then here C double bond O, right? So here C double bond O, here pH. Now in that this hydrogen and this oxygen combined together, and the same way this hydrogen and this oxygen combined together, you will get what it is? Intramolecular hydrogen bonding. Intramolecular hydrogen bonding. So intramolecular hydrogen bonding, it is more stable, more strong, right? So definitely this will be more stable. This hydrate formation, it is more stable. Right now, which is less stable only they are asking. The second point, option B, this is right now phenyl group, which is attached with the pentanone 3 what it is? Keto group is available. Here one keto group, here one keto group, and here combined with the water. Here also Geminal diol formation. See, in this point, the geminal diol, what do you mean by geminal diol? Same carbon which is attached with the hydroxyl group. Now, adjacent carbon which is attached with the hydroxyl group, that means a functional group, means that is vicinal. Geminal means the same carbon which is attached with functional group, that is geminal. Right now, here also, geminal diol only you will be getting. I hope you got that clarity, what is geminal and vicinal. Right now, here also geminal, here diol, OH, functional group. Right now, C double bond O, C double bond O here. Now, in this also, you can find what it is. This hydrogen combined with this oxygen, and the same way this hydrogen, this combined with oxygen. Here also, you will get what it is, intramolecular hydrogen bonding. So, intramolecular hydrogen bonding, which is more stable hybrid ion, right? I hope you got the clarity. Now, this point, which is called same carbon, same functional group, which is attached to that same carbon, that is called geminal. Now, vicinal means adjacent carbon which is attached. Now, third one, cyclopropanone. Third one, what it is, cyclopropanone. So, cyclopropanone, what it is, C double bond O, combined with the water molecule. Here also, you will get geminal diol, same carbon which is attached with hydroxyl group, two hydroxyl group, right? OH and OH. Right. Now, this is actually, this is sp2 hybridization only, but here sp3 hybridization, this is sp3 hybridization only, but angle strain which is very less. Angle strain, which is very less, okay, less angle strain, right? Now, this is cyclohexanone we are checking, that is what I just mentioned, angle strain here. Now, this is also cyclohexanone, double bond O, here also sp2 only. So, this is angle strain. Comparatively, here what happened, this is actually what it is. Here also you will get the geminal diol only, but this is unstable comparatively here. This is actually what it is. Very unstable, so it releases water. Again, it forms what it is, cyclohexanone. Again, it forms cyclohexanone. It will not be stable as it is. The same original compound only it has become. But here, angle strain less leads to more stable. Angle strain less leads to more stable. Right, so this angle strain, it is very less comparatively cyclohexanone. Now you see this angle and this angle. So angle strain less, this is 3-membered ring, but this is 6-membered ring. So this will be more stable comparatively this. This also keto group, this also keto group. When it is cyclohexanone, cyclopropanone. So which is more stable, which is least stable, means cyclopropanone, it is more stable. Of course, this is also stable. This comparatively, all these are stable. This is also stable, this is also stable. Now comparatively, these two things which is more stable means cyclopropanone, it is more stable. Which is least stable means cyclohexanone, which is very least stable. That means unstable. Okay, unstable. They are asking which is less stable, least stable, unstable. So cyclohexanone, what happened here? Actually, we are getting what it is. Diol formation, geminal diol formation only we are getting. But still, it releases water. Self-condensation reaction takes place and it releases water. Again, it can go to the original reactant compound like. Okay, so which is the correct option? Option B is the correct option. They are asking that question, which does not form stable hybrid on addition of water. So option B does not form stable formation. Okay, so which is least stable or unstable? Does not form stable, so unstable. So this is unstable. Alright, so I hope you got the clarity. All this is hydrate formation takes place due to intramolecular hydrogen bonding. Alright, yeah, come on, let us go to the next question. The next question, consider the following sequence of the reaction. Ketone A combined with ethyl magnesium bromide along with water hydrolysis, you are getting product B. That B product combined with H2SO4 along with heat, releasing that water, you are getting compound C. That compound C combined with ozonolysis along with zinc dust, water molecules, you are getting ketone plus aldehyde. Right, now which keto group is that reactant compound A? Let us check. See, generally concept, it is very easy to identify the answer. Right now, keto group here, the first one, keto group combined with Grignard reagent. So here ethyl magnesium bromide, right, along with water hydrolysis. So see, keto group combined with Grignard reagent, definitely you will get tertiary alcohol. That is a common concept, alcohol, right? So this is a compound A and this is a compound B. This compound B combined with the H2SO4, right? H2SO4 while heating, and it releases water. See, generally tertiary alcohol combined with H2SO4 while heating, you will get elimination reaction takes place and you will get alkene. I hope you got the clarity. So this is a compound C. Okay, why it is we are getting alkene means elimination reaction takes place means because it does not have alpha hydrogen. So naturally it releases water molecule and you are getting what it is, alkene is the product. Now alkene combined with ozonolysis, right, ozonolysis along with the zinc dust with water molecules, you are getting compound, or that is a keto group along with here keto group along with what it is, acetaldehyde, CH3, CHO. That is what it has mentioned now, CH3, CHO. Right, this is CH3, CHO. Yes, got it. Right, now which keto group it is correct? That is the question. Now here, this is actually 1, 2, 3, 4, 5. In the third carbon only, keto group is available. Right, now in that, what it is? Ethyl magnesium bromide, which is adding. So tertiary alcohol we are getting, of course, and elimination reaction we are taking place. Added to that ozonolysis, you are getting 2 carbons which is away from that. So that means this is terminal carbon which is having that keto group, methyl keto group, which is not possible to bring that acetaldehyde. Generally, here keto group, if it is there, means combined with what it is, ethyl group. So that means here only ethyl group will be there. So the double bond formation comes over here. So elimination reaction takes place, means you will not get this kind of group. Here you will get formaldehyde combination you'll be getting. So this will not be the correct option. Okay, now this is actually, it is possible because 2 carbon is available. So here also acetaldehyde 2 carbon it is available. Yes, let us check. This is hit and trial method. And this is also terminal keto group it is available. This will not be possible. And of course 100% this will not be possible because here 5 carbons are available. So this will not be possible. Okay, let us check with this compound. Okay, each and everything, this is just like what it is, a concept based, right? Alright, let us check with this compound B, option B. Why I have categorized this, for that easy to understand that idea. Right now, this is like this only now. So this is combined with C2H5 MgBr. So along with water hydrolysis, so you will be getting what it is, tertiary alcohol, right? So this point only you will be getting tertiary alcohol. Here OH, here CH2, CH3. Right, CH2, CH3 I just mentioned. Here C2H5 also you can. So this is compound A, this is compound A, and this is compound B. You are getting, this is a tertiary alcohol. Right now this is a tertiary alcohol, Right, now this tertiary alcohol combined with what it is, H2SO4. So H2SO4 while heating, so it releases water. So what you will be getting, same this, here you will be getting what it is, double bond CH2, CH3, right? Now here OH is there. No, in that OH one hydrogen which is taken and releases water. So this is an elimination product. This is an elimination product which is called alkene. Right, alkene only which is reacting with ozonolysis. That is the reason. Right now this is an elimination reaction, H2SO4 combined with the tertiary alcohol. You will get alkene only. Why? Because this is actually, it does not have alpha hydrogen. That is what I just mentioned. Right now here ozonolysis. Here what it is, ozonolysis, O3 combined with zinc dust along with water molecules. So you will be getting what it is. So the product is actually here. So the bond breaks over here, no? So here you will get one oxygen, here oxygen and one more oxygen which is releases with zinc oxide, right? So you will get that compound like this. So you will be getting like this. Here one oxygen, no, the bond breaks over here. Here one oxygen, here one oxygen. So here one oxygen means acetaldehyde, here one oxygen means ketone. So that is what, see, this is a keto group and this is CH3, CHO. So acetaldehyde and this is a keto group. I hope you got the clarity now. Which is the correct option? See, generally sometimes if we know the concept, a hit and trial method, we can bring the answer. Exactly. So concept, it is very, very important. Our guess is correct. Yes, this is the correct option. Option B is the correct option. Yes, option B is the correct option. Why option B is the correct option? Because terminal group, that is actually 2 carbons are available. This is a key point for us to identify. That is what I just have taken this point. Whereas this is a terminal carbon which is having methyl keto group. Methyl keto group, when it is going for elimination reaction, you will not get acetaldehyde. You will get formaldehyde, right? So that is what formaldehyde when it is going for ozonolysis, right? I hope you got the clarity why this answer it is correct, whereas other answers are not wrong. Come on, let us go to the next question. The next question, in the reaction, here this compound reacts with acetone CH3COCH3 along with ethoxide ETONA, that is sodium ethoxide along with ethyl alcohol. While heating, you are getting product X. So what is the product? Come on, let us check. See, directly we can go to the reaction so that it will be easy for us to find the answer. That is what specialty of organic chemistry. So directly we can go for the reaction. Right now this is actually product. So this is double bond, here sp2, here sp2, here sp3. Right now here combined with CH3COCH3. So before going to react with this, it's attacked by sodium ethoxide ONA. Right, sodium ethoxide combined with ethyl alcohol ETOH. So this is a plus and this is minus, no? So this is actually here CH2, right? Here one hydrogen, here one hydrogen, right? So this is double bond, both the side double bond CH, but here CH2. So this is actually minus and this is acidic hydrogen, right? So acidic hydrogen. So acidic hydrogen, what it is? It releases that proton and forms what it is. It is going to attract it towards the minus charge. So it releases what it is, ETOH. Right now here ETO and here it is an ETOH. Right now here what it is, here minus charge will be created. So this point here like this will be there. Now this is double bond, here minus charge. This minus charge which is reacting with acetones, that is CH3, C double bond O, CH3. This is a carbonyl carbon. Right now this is actually this minus charge which is attracted towards what it is, this positive charge, of course. Right, this is negative charge. So this is positive charge now. So this negative charge which is attracted towards the positive charge, carbonyl carbon. So naturally what happened? So you will get the product here like this. Right? Double bond, here double bond. Right now here C, here CH3, and here also CH3, and here O minus you'll be getting. Now this O minus undergoes with water hydrolysis, HOH. So you'll be getting what it is, tertiary compound. You'll be getting like this compound. Right, here alkene, this. Now here carbon, here OH. And the same way, of course, this is CH3 and this is also CH3. Right now, this is a tertiary compound you'll be getting. Right now, yeah, come on, let us check the answer. I hope you got the clarity. How do we get this answer? So this is actually before reacting with acetone, that is methyl keto group. It is attracted towards that positive charge. So naturally, it releases what it is, ET, that is ethyl alcohol, and this negative charge which is attracted towards that carbonyl carbon. So you are getting this way, and finally you are getting that product. Now which is the correct answer? CH3OH. Here CH3OH, it does not have OH, so this will not be the correct option. Of course, this will not be the correct option here also. Alcoholic group which is available, see here oxygen is available, right? So here acetone, still it is alive, that from there only oxygen is available. Like carbonyl group only, it gives the tertiary alcohol. Now which is the correct option? Option B is the correct option. I hope you got the clarity for all these questions. Come on, let us check the next question in our next video. And thank you for watching, and thanks for your great support